Hello, this is the DAX Visual Calculations, what you need to know session. About me, I'm Renato. I'm a data platform MVP from Brazil. I have a blog post, I have blog, and I'm specialist from the self-service part with N and DAX languages, and learning about this stuff called Fabric. Visual Calcs was a really new feature released in last February 2024. And until it reaches GA, it might change. And there's a lots of improvements planned. The people behind this feature are known for their long-term implementations, such as composite models. And we are waiting for more detailed blog posts from Jeffrey, the father of this beautiful language called DAX, and the Italians from SQL BI. They already had one. Let's see a little bit about this feature. First of all, I'm going to use AdventureWorks sample database. It is a preview feature, so you need to go to Options, Preview Features. There's a lot of preview features, and one new, the scroll bar here, you go all the way to the bottom and enable the Visual Calculations one. Once you enable it, you can start playing with the model. The model is the AdventureWorks, fact sale, and several dimensions around here. Okay, so I have already a matrix visual here with the country region in the row segment and the color and category in the column segment. I can filter for black and blue colors, so we can all see in one screen. And I see the numbers, but how regular DAX feeds the Power BI reports those numbers so the visual can render and put it in a bar chart, for example. And it always, in every visual, you can see here, show as a table. And you can always see the underlying data that the DAX query, the analysis services engine, gave to the visual for it to work. But now we have this new calculation button up here. And I can also right-click and add a new calculation through here. And here I have some templates that I can do some tasks that in regular DAX are not that easy, such as running sum. And then I choose my field. My field is sales. And then I have the running sum for that sales. So 87, and you can see it's actually computing the right amount with a really simple function. You don't have to do calculate and filter gymnastics to actually achieve the desired number. And that's what business users actually do. They see numbers and they starting doing math on their head, summing, dividing, and doing things on top of what they are seeing, not the data model, okay? So we also have some other examples such as moving average, percent of grand total, percent of parent. Let's do this one. I put sales here, and I have to specify the axis. That's a new concept that Visual Calculations introduces. You can use either rows, columns, or columns, rows. We'll get to that in a little bit, but let's use rows, which is the most common one. And then I can see that right now you cannot format, but it's in the roadmap. It will eventually get here, and we should use some format DAX function to properly show the data in the way we want, okay? We have several other functions, such as versus first, versus last, previous, next, things that are very intuitive to business users that are mostly used to Excel, but in the DAX realm, it's not that easy. But now with visual calculation, we kind of fill that gap. So, for example, I can add another visual calculation, like first equals, guess what's the name of the function is. First, I want the first sales, and I have the first sales for every row, okay? If I don't use the axis argument, which is the second argument here, the default argument, the default axis will be rows, unless there is no rows selected to the visual. So you only have columns, it will use columns. Otherwise, it will use rows as a default. And I can write it rows. And if I go in, I can also hide the calculations that I don't need to show at the current visualization. Because I might use some intermediate steps, intermediate visual calculations to achieve my last one. And when I'm ready, I can come here and hide the unnecessary ones and just show what I need, which is the first. Here, it preserves the sort by that you select on your visual. As you can see, I can use here, sorry, let me restore. If you want to go back to the edit mode for visual calculation, you can either right-click, add a new calculation and skip, or you can come here to the values and click at edit calculation. Let me restore the sales, okay, and go back. So I can see the sales, and I can see the first sales for the black accessories and for the bikes black and so on. They're always the first, the first that we can see here. But if I change the sort order of my visual, for example, by country region, the visual calculation keeps the new sort order and then changes the number. I know some calculations require some specific order. In the future, there is in the roadmap the ability to do that, but you can do, by the end of the session, using functions, and I guarantee I will override the visual's sort order and use another specific sort order to make sure my calculations are the same. But mostly, what the users want to see is the way they are seeing, so the sort order of the visual. Okay. Another thing that I want to show you here is that if you see the total row here, this is DAX. Every number that you see here was calculated separately. There's no this 160, even though it is additive. Sorry, it is additive. It is not an actual sum of the previous one. And I said first, I might wanted to expect to see 25, not the 160 here. But totals are calculated in a different level, and I have a measure here, sales wrong. I will put it here, remove the old ones. It will break my visual calculation, but I can just rename, and everything goes back to normal. And what that sales wrong does, it puts -1 on every total. And as you can see, the total part is completely independent from the rest of the data that I can see here. And it is really important as well, not just in regular DAX, but also in visual calculations, to fully know and manage that. Let's go back with the correct sales and go back to the slides. Okay, first, visual calcs is DAX. That's not a new language, it is still DAX. And you still need to know DAX to fit the visual matrix, that bottom part that we showed before, with data, including totals. And Visual calcs introduces new functions, such as firsts, running sum, moving average that we covered so far. Question? Uh, the question was, can you see what the visual calculations is doing underneath, how to achieve the calculation? Yeah, not directly, but there are ways that we can go and through the presentation, we're going to try to put a spotlight on top of that. Okay? And it introduces new functions and concepts to our DAX tool belt. That's just different. There are two separate words now. There's the regular DAX and the visual calculations. The regular DAX relies on the data model or the semantic model, and the visual calculations relies on the visual matrix. What you see is what you get there. In the regular DAX, there's this unique concept called measures. You can set up a calculation that works in any scenario, no matter the group by columns you might choose for a specific query. In visual calculation, what you see is what you get. All the numbers, you don't have access to the data model anymore. All the numbers you use are already seen on the regular data that the visual required from the data model. DAX is based on abstract context. So row context, filter context, they are quite simple, but when in reality, people get confused. And visual calculation, by the way, last year I was here at SQLBits, that is on YouTube. I have this calculate evaluation order session. I try to cover those concepts. If you want to see, that's a good session to rewatch. And with visual calculations, we have enhanced navigation capabilities. Those who came from the MDX world, it's kind of like that. I'm not that old. I've joined this word, DAX already existed. And with regular DAX, you have limited resources for sorting, because one of the optimizations of the semantic model is actually the V-order. It shuffles the order, so if you rely on a calculations that points to the previous, the first, the last, the next, it gets messy. But with visual calculations, we rely on the visual sort order. There's an option to override it, but the order matters, and I can now calculate versus first, previous, last, next. So with the semantic model, there are some concepts that for the regular business users are hard to acquire. And with the visual matrix, the visual calculation, you have the visual matrix, which is the bottom part that you see in the edit mode, with all the numbers that you can play, including the totals, okay? And with visual calculations, you cannot, okay, I want to see that my value from that table from that model. No, you don't have to access to the model anymore. What you see is what you get. So the visual matrix, depending on the visual, every visual has a contract with the semantic model. It has its own way to ask for data, it has its own way to write a DAX query that is automatically generated for you whenever you click, where the drag drop, you click and you do your Power BI reporting stuff. So the visual matrix adds a sequence of hierarchical group by fields per axis. This is a new concept, axis, rows and columns. They are the foundation of this visual matrix here on the DAX language. So you can do calculation columns by columns. In the first row, first column, first row, second column, third column, and so on. And then go to the second row and restart doing the calculations, or row by row, which is the calculated column that is wired in every Excel business user or even developers. So there's one problem here. when I start scanning for that row every column, or when I stop scanning for that column every row, the calculation restarts. That's what we saw in the demo. So to solve that, they created the columns, rows, rows, columns. So whenever I am in the first row and I go through every column, when I go to the second row, the calculation keeps that memory of all the previous rows with that specific path. The icon choice here was perfect. It's very intuitive here. Okay, so the visual matrix has a natural border that we can erase it with the columns, rows, or rows, columns. Demo time. Okay, we talked about axes. So let's play with axes. I can either go to edit calculation or right click, new calculation, hit ask, okay? I'm gonna get rid of some of previous calculations here and go back to the running sum sales, and shows you if I don't specify the axis, the default is rows if there is a row present in the visual. Otherwise, it uses columns. But I can play with the axis. I can put here like columns. And you can see here, running sum, the first running sum, which adds 25 to this number. And then you can keep doing that for every new column on that specific row. But in the next row, the calculation resets. That's why they created this other axis reference, for example, columns, rows. That, okay, keep doing the calculation by columns. Whenever you hit the end of that row, keep the memory. So we can see here that the running sum here starts really big, and if you go all the way to the right, that's the number we can see here. Okay? Totals. As I already shown you, the totals are a different kind of calculations. So if I put the sales wrong back here and rename it, we can see there is a running sum with the totals, -1, -2, -3, but it kind of lost that inner part. That's what we intuitively would hope they should use. So the totals are in a different level, and we're going to talk about levels in a little bit. That's why that's a completely different calculation. And what you see is what you get. As I said, let's go back to, I have a second example here. Let's just restore the sales one. And I have a second example here. I have the hierarchy of year, quarter, month. And I can add a new calculation. And let me just see the right name, month key. And here I can put, the IntelliSense doesn't help me, but I can do calculations with month key. Who knows why I can do that? Because what you see is what you get. You can only reference fiscal year, fiscal quarter, country, region, or categories. But I reference a different column that exists in my model. Why can I reference it here? Yes, the sort by option. Whenever you have a column in your model, for example, the month, there is a sort by month key. And in the DAX query that is automatically generated, it adds that month key in order for you to have the right sort order with the numbers, not the alphabetically. So it is hidden, but we can access those extra sort by columns whenever I put an axis to that. Question?
Say you have like lots of filters or slices, can you access those as well without then filtering that table?
No, slicers and filter. The question was, if I add some slicers and filters, can I add to a visual calculation? No, slicers and filters are outside from the current visual. You're doing with visual calculations inside this new visual. So only the fields that you add to that visual are you are able to reuse. They are, though, the slices and filters does affect that visual. So as the example was shown, I filtered the color to black and blue. So it does take effect, but I cannot use them and restore. Question? No, the question was, can I take group by columns or rows and hide them? Currently, not. You can only hide the numbers that came from measures or other visual calculations. Okay? Let's go back to the slides. So, there is a new context here introduced by visual calculations. That there's no official name, but since SQL BI posted a blog post last year calling it visual context, I think we have a name here. So it helps you navigate through the different combinations of different levels in that visual matrix. So you can either access every combination at the current level, or you can navigate through different levels. We're going to see some examples in a little bit. The name is not official because this didn't came from Microsoft, but the candidates could be visual, navigation, axis, level, hierarchical. The point for these sessions is I'm going to try to introduce this concept so we can better achieve our calculations. So there is a really important concept that I call the number of internal levels. I call R the number of rows that you added to the visual. I will call C the number of columns that you added to your visual. Therefore, the number of row levels is 1 plus the number of group by columns that I added. The number of columns are 1 plus the number of columns that I added. And remember, why do I have this plus 1? Because I can put in a visual matrix, for example, only things on the rows, nothing on the columns. But I still see numbers. It is the total part. The total is absence, no filter in that level. So we have that extra level per axis. So the number of total combinations within levels is the product of the number of levels per axis, which is rows and columns. Okay, so for this example, which is the main that I'm working here, how many levels there are? How many group by row fields we have? Let me help you. Only one. I only put customer, country, region to the row level. And to the column level, how many do I have? 2. Therefore, the number of combinations, the levels per axis, I have 2 row levels and 3 column levels. So far, so good. So I have 6 different combinations of different levels per axis. And we're going to see each and every one of them. There's the combinations of the no filter at row and the combinations of the column axis, and the combinations that includes the country region and the combinations of the columns. This first example, it only, if you see the visual matrix, it only refers to that cell. No filter. Number two, sorry. Number two, I have two different combinations because now I'm still on total lane here on the row axis, but I go to, okay, filter by column. Here, in this specific example, I have two combinations that refers to those two numbers from the sales. Here, things starting to get more interesting because I'm still on the total per country region, but it is a hierarchy. So I'm filtering both by color and category. So I have all those combinations for black and the 4 categories and blue and the 4 categories. And whenever I pick one of those combinations, I can refer to one of those numbers. Okay, let's filter by country region and see the total per columns. I can only see those numbers, highlighted numbers. Now I see more combinations, 14, because it's 7 country regions for color black and 7 country regions for the color blue. And lastly, what is the most part, at least for me, when I see the visual matrix, I keep my eyes only see that middle part is the highest granularity level, which is the combinations of all group by columns that fed this visual, which is country region, color, and category. Okay, so we have 55 different combinations that uniquely identify each and every one of those numbers that we can see here. So far, so good? Okay. So if I do some new visual calculation that puts here count rows, either rows columns or columns rows, in this case, doesn't matter. Okay, but if you're using running sum, moving average, it does matter if you use one or the other. But for this calculation, I'm just counting the rows. The output is the same. And you can see here that every combination that we highlighted in the previous slides, the numbers are here. 56 for the highest granularity, 7 for the totals of the rows. Oh, sorry, that's okay. And let's go back. And 14 for the totals per color. So underneath, whenever you reference and you use those axis rows, columns, rows, you're actually receiving a table. And you can count the rows of the table. And what is that table? It's the combination that uniquely identifies every field in that specific level combination. I think it's gonna get more clear going forward. So if I change the calculation, I count the rows only for the rows part, we can see 7 all over the place, but in the total, which is another level for that specific axis. And we change again, count rows now, the columns reference, and we can see all the 8 for the highest granularity, which is the black and blue for every category combination, 2 for the total, this intermediate total here, which only filters by columns or either black or blue, and 1 for the grand total. All right. So when you use an axis reference, rows, columns, rows, you see all the possible combinations for the current level without filter. If you think about regular DAX, it's as if I was wrapping it with the all function to return a table, but you don't need it. If you really need to intersect all the combinations of the current level with the current level filter context, which we're gonna talk in a little bit, then it pinpoints and only sees that specific level. One thing, I don't think you'll notice it, there is no combination between category and country region. Because category is in the column axis. And first, I used, as a first layer, the color, and as a second layer, I used the category. And this hierarchical way of feeding the visual matrix leaves out that combination, okay? So whenever you do use visual calculations to make calculations, you have to be really specific on what order you're gonna feed your axis, either rows or columns, because you're missing the category and country region, or the category and row total. So here we don't have the row context, but we still have the exact same filter context that we are used with the regular DAX. So if I highlight this cell, think about regular DAX. What is the filter context? Easy, right? And sorry?
Country region is Canada and black and coding.
Perfect. Country region Canada, black and coding. But now, with visual calculations, we have to think in another context, the visual context. Okay, what is the rows level? What is the columns level? So, as Lars said, the country region is Canada, color black, category clothing. And the level is 2 and 3, because the first level, my convention here, the first level is always the grand total. And then whenever you're going through the hierarchy, you add 1. So the rows level is 2, and the columns level is 3, because I'm under black, and the color and category. It's supposed to be easy, right? This highlighted cell, couple of minutes to think. Color black, category components, but there's no need to set a filter in the country region, because in that level, I don't have a country region granularity available. And when you think about the rows and columns levels, as I am the grand total part is level 1, and the column level is still 3, because I'm filtering by color and category. This one, couple minutes, I'm gonna fast forward a little bit. Country region is UK and color black. There's no need to filter category, and the levels are 2 and 2. Okay? So you can do this exercise for every cell. And the last one, slide I have here, this one. Perfect. Level 1 and 1, and no filter at all. Okay? This exercise you can do with regular DAX to identify the filter context that come from that current visual. Okay? So, with all of those 6 combinations of levels between the row and the column axis, I can have like a hierarchy. So I have for the row axis, the total as level 1, and the country region as level 2. And for the column axis, I have the total, color, and then category. And the new concept that was unnamed until a week ago when SQL BI posted their blog post, which is the visual context, is how can I navigate through the hierarchies. I can go up in a higher level, or I can go down in a lower level. And they introduced those couple of functions, actually 4, that if you want to go up to a higher level, you need to use the collapse function. And if you want to go down, you use the expand function. There are some other parameters, and there are some functions that would go to the highest level, either the highest or the lower level, which is collapse all and expand all. Okay? So the collapse reduces granularity and expand increases granularity. Demo time. Oops, not Excel. So if I go back here, I already have it pre-set up. We are behind it, the time. So I can see two new visual calculations expressions here. I have the collapse and the expand. So let me see I think I put per column the edit calculation. The collapse one is this syntax, sorry. You can use this syntax, collapse, what field do I want to reach, and collapse which axis. I want to go up on the column or the row axis. And this is an alternative way to use it with calculate. We're going to cover that in the slides later. So here, I'm collapsing this level seeing the column, which is this value, 29. 2.9, 2.9. I'm going to a higher level to see the values. And we have the expand, the regular version in the syntax sugar one. That now, in the first argument, since we are increasing granularity, you have to use some function to summarize it. Either sum, average x, count rows. So we are in a level, we are going to see a new level, more rows, therefore we have to use some count rows or sum to achieve that functions. Okay? So under the hood, the input table is almost the same. If you see the DAX query generated, I don't have time to guide you through here, but if you see the DAX query, please read the SQL BI article. They've done, as always, a pretty good job dissecting the information. The input table for a visual calculation is this one for my specific scenario, which is the country, region, color, and category fields with three totals, the grand total for rows, the grand total for columns, and the intermediate totals if I have more than two group by fields that was set to that specific axis. And then the regular DAX. So those three columns are filter context. This middle part is the visual context. So it always has been there with DAX. If you examine the DAX queries before, there's always the grand total, but now visual context controls it in a more specific way. And then the regular measures that came from regular DAX. So that's what you see is what you get. So with this, you can sort the axis and perform the calculations that you actually need to. So if I see, for example, the grand total row filtered, it's as if I'm in that grand total row. I only need to specify the color and the category to pinpoint and pick the sales or any other field here. And for example, if I put this DM2 total, which is the intermediate total, which is the column axis filtered only by columns, not the category, that there's more rows that you can see in the print and the screenshot. But we can see all of the combinations because the visual context filters those totals, the true and false ones, and the visual context filters the actually fields that we are used to work. Okay, so if I have a filter context at color blue and category accessories, I can access the sales amount that came from the DAX query. I can access the category or the color. I can use those collapse and expand functions to navigate to other levels and handpick other specific values. So it is quite powerful. So these totals determines what is the combination of levels that you are in and what you're seeing in the visual matrix. Internally, what visual calculation is doing? On top on an input, which is pretty much the same input every other visual always asked for, the semantic model to fill that visual, it adds this visual shape part, where you determine the axis, either rows or columns. You can only have rows or only have columns. And per axis, you say, okay, I'm gonna group by country region, and the total for this, the extra level that is added, is in the filtering by that grand total row. Same for the column, and here it is really important. It uses the sort by that the visual actually have. Same for the columns. Here I have two fields that I fed to the column axis. And there's this densified, which is an internal tag that is undocumented, but I think SQLBI is going to do a blog post in the following months. So whenever I add a new calculation, it's like a new column to that table from the previous expression. It adds two more extra columns to that. The isDentified row, which is an internal handler, and the actual calculations that relies on that visual shape definition. And the visual shape definition, they have the order for every axis. Therefore, I can navigate through them and through the levels also. So there are new functions that visual calculations introduced. Are you hearing me? Okay. There are new functions that visual calculations introduced, which is all of the functions that we saw. They're categorized into high, medium, and low-level functions. When you go to the low-level functions, it becomes a little bit harder. The high and medium are visual calculation exclusive. You cannot use it in regular DAX. But the low-level functions, which is more than a year ago were released, they are the foundation for the visual calculations. And they can be used either in regular DAX or visual calculation context. There are differences on the parameters. For example, you can use rows, columns within the visual calculation context, but you cannot with the regular DAX. So same functions, but different arguments that you can feed them. Okay, and when you take visual calculations, for example, running sum, when you actually passing, I'm passing the row part, internally it's doing the regular, the window function, the low-level one. Window from the first absolute and the current relative. I didn't put relative, but if you don't put, you assume it is relative per row. You can use the axis plus reset, and it filters accordingly to the selected axis, respecting the filter context. So when I put I love this function, toCSV. You can see the tables internally. When you put toCSV, that window function, what you get here, as I'm passing the row argument, you get the exact same values per row, which is the filter context combination that defines that specific cell. For example, here, I have a country region, the running sum. So this window part is relative to the running sum. So I have the running sum equivalent per row. Same for columns. The values are exactly the same if I see column by column. And if I see row by row within a column, it is adding the specific new value that groups every combination that is used to compute the running sum itself. If I use row columns, you can see here it first by row, and I have extra columns that I can fit in here in the slides. But when you go to the next row, it keeps adding the stack. So internally, they are manipulating the filter context and then performing the calculation with what we expect. Let's fast forward a little bit. So possible syntax sugars that we might have. Okay. Running sum x, that window function, sales. And if you notice here, there is no calculate to force context transition. Why? Because in visual calculation realm, there's no row context. There's only filter context, and that visual context that we can navigate through the different levels of the hierarchies. So you can further, we actually don't have the right answer, but there's an alternative way to write it, which is calculate sum, and then the window as a filter argument. It works as well. Moving average, same thing. I can use a middle level function called range with the same arguments. This false one is include current or don't. I only have 5 minutes, so I'm gonna pass through. And you can alternatively use a calculate expression with the range as a filter to achieve the same output. Or range is a middle level function. You can use the low level function using the window part. So you have to know that? No, but if you know, you are able to do some more complex, intricate stuff. Previews, the same, offset, and the same logic you can use with first last. Instead of using offset, you can use index. Okay? And then there is collapse. Calculate version, expand, calculate version. Internally, they're equivalent. And the sum internally is something like sum x values of rows columns. Why values? Because rows columns, I have every combination for the current level. Values, I restrict the scope for that specific cell. It's easier than regular DAX, but you still need regular DAX. It's perfect to enhance regular DAX measures with stuff like that on the templates that otherwise were pretty hard to do, not intuitive. But because it's easier, people like easy, right? People will tend to overdo things with the easier part. And we all know the Rothschild's maxim. We are supposed to do things as upstream as possible and as downstream as necessary. I'm gonna rush it because I don't have any time. But if you see, Visual Calcs lives as downstream as possible. So it might introduce some problems. So there are some red flags. It lives in the visual, the report. If you change some specific logic, you have to find and change in every other and probably miss some. It doesn't solve the recursion problem yet. And there are some other things, as one previous question we had here, that are on the roadmap. Eventually, they will get resolved. So if you support my case for hanging the visual calculations, not in the visual, not in the report, but hanging it in the model part, please vote for this idea, because there are plenty of great things, but this is a really thing. I think that I hope they would choose differently. And I'd like to thank you for this session, and there's a feedback. It's really important, please, Phil. Thank you very much.